everyone, and welcome to today's webinar, Securing the Software Development Lifecycle, Addressing Modern SDLC Security Risks, hosted by BlueFlag Security. I'm Maura Ghazani, VP of Product Marketing, and I'll be your moderator. We have a really insightful discussion ahead featuring two industry experts. First, we'll hear from Katie Norton, Research Manager for DevSecOps and Software Supply Chain at IDC, who will provide IDC's latest research and insights on SDLC risks, security risks, and trends. Then Raj Mallempati, CEO of BlueFlag Security, will give an overview of how BlueFlag is addressing these challenges through our very unique identity-centric approach. We'll leave time at the end for Q&A, so please feel free to drop your questions in the chat throughout the session. And with that, let's get started. Katie, over to you. Thanks.
Thanks, Maura. All right. So the software development lifecycle has really become a prime target for attackers, and we're seeing consequences, major breaches, rising regulatory scrutiny, and increased business risk. So today I am going to take a look at three core areas around securing the SDLC. First, we'll talk about why SDLC attacks are increasing. We're going to examine some real-world breaches and how they've led to new regulatory pressures, and we'll also explore the business impact, including how these attacks are driving ransomware incidents and affecting organizations. Next, we'll explain how to understand the SDLC as a supply chain and identify the three most critical attack vectors within it. That would be developer identities, toolchains, and third-party dependencies. And we're going to also talk about how they create security blind spots that attackers are exploiting. Finally, we'll shift to the solutions. We're going to explore what an effective SDLC security and governance platform looks like and the key benefits it brings, not just for security teams, but for developers, operations, and the business as a whole. By the end of this presentation, I hope you'll have a really clear understanding of why securing the SDLC is now a business imperative and how organizations can proactively defend against emerging threats while enabling faster, more secure software delivery. So today, cyber threats are no longer about just breaking into networks or exploiting application vulnerabilities. Attackers are realizing that instead of trying to break software after it's been deployed, they can poison it at the source by infiltrating the SDLC. This shift in tactics means rather than looking at weaknesses in production applications, adversaries are targeting the very process we use to build, test, and distribute software. Modern software isn't built in isolation. It's a really interconnected system of third-party components, open source libraries, CI/CD pipelines, cloud services, and developer tools. And every one of these dependencies represents a potential entry point for attackers. So what makes this shift especially concerning is the scale of impact. If attackers compromise a single development tool, a widely used package, or a privileged engineer's machine, they're not just breaching one organization, they can compromise an entire supply chain. And this isn't theoretical. We've seen real-world attacks that prove just how vulnerable the SDLC has become. And I'm going to go through a couple of them. SolarWinds, for example, is one of the most infamous supply chain breaches. Attackers compromised SolarWinds build system, injecting a backdoor into its Orion software updates, which were then distributed to over 18,000 customers, including government agencies and Fortune 500 companies. This attack really exposed the dangers of build system vulnerabilities, that if an adversary gains access, they can distribute malicious software at scale, infecting countless downstream organizations. In the CodeCove breach, attackers compromised the Bash uploader script, and that's a really widely used development tool. This allowed them to exfiltrate environment variables, potentially including API keys, secrets, and cloud credentials from their CI/CD pipelines of hundreds of customers. Third, unless you've been living under a rock since 2021, honestly, everyone is familiar with Log4j. While this wasn't technically an attack, and more so a vulnerability, the potential impact that the Log4j vulnerability had is staggering. Research done at Google found that at the time, more than 35,000 of the available Java artifacts on Maven Central depended on the affected Log4j code. The LastPass breach took a different approach. Attackers compromised a senior DevOps engineer's home computer, by exploiting a vulnerability in a third-party media software. This wasn't just an isolated attack. The engineer had access to decryption keys for LastPass vaults, meaning that a single compromised machine led to widespread credential theft. And this highlights a new attack vector: remote and hybrid work. Developers working outside corporate security perimeters can be targeted at home. And if they have highly privileged access, a single breach can lead to a catastrophic compromise. The New York Times breach involved a stolen GitHub token, which allowed attackers to access over 5,000 private repositories containing 270 gigabytes of IT documentation, infrastructure tools, and source code. And that included the viral Wordle game. This attack exemplified the risk of misconfigured or exposed credentials in code repositories that can give attackers direct access to an organization's core intellectual property. And then finally, recently in October 2024, the Emerald Whale campaign represented a perfect storm of SDLC vulnerabilities. Attackers exploited open repositories, hard-coded credentials, and cloud misconfigurations to steal over 15,000 cloud service credentials. This highlights a real key lesson in the SDLC. Attackers don't rely on just one weakness. They often chain multiple exposures together. So these breaches have exposed the gaps in software supply chain security, and that has led to increased regulatory scrutiny around how organizations secure their SDLC. So let's take a look at 4 key regulatory actions that are forcing organizations to rethink and strengthen their SDLC practices. The SolarWinds attack was sort of a wake-up call for, especially in the US. The US government, in response, launched the Executive Order 14028, which was enacted in May 2021, and that required companies selling software to the federal government to improve their software supply chain security. A key part of this order was the call for software bills of materials, or SBOMs, and this had a ripple effect across industries, making SBOMs a new standard for tracking and securing software dependencies. To operationalize the executive order, the Office of Management and Budget issued Memo M2218 in September 2022. And this memo added accountability by requiring software vendors to self-attest that their software follows security best practices based on NIST's Secure Software Development Framework, or the SSDF. In December 2024, in Europe, we saw the European Union pass the Cyber Resiliency Act, which goes even further by placing legal obligations on software vendors and device manufacturers to improve their software supply chain security. This regulation recognizes that third-party components and open source software are critical attack vectors. And then finally, the SEC's cybersecurity disclosure rules, which took effect in December 2023, have a direct impact on how publicly traded companies secure their supply chains. Organizations are now required to disclose cybersecurity incidents, including those that affect their software supply chains. And that means that a software supply chain attack is no longer just a security issue, it's a financial and regulatory risk. Investors, regulators, and customers are demanding transparency on how companies are securing their SDLC. So the key takeaway from these regulations is that securing the software development lifecycle is no longer optional, it's a compliance necessity. So we've talked about how threat actors are targeting the SDLC and how regulators are stepping in to enforce security, but beyond compliance, failing to secure the SDLC comes with real business risk. First, let's talk about trust and market reputation. Today, a single software supply chain attack can make headlines, damaging your company's credibility overnight. If customers and partners can't trust your software, they don't trust your business. Breaches expose customer data, intellectual property, or sensitive software components that lead to lost contracts, lawsuits, and long-term reputational harm. Once that trust is broken, it's incredibly hard to rebuild. Next, operational resilience is at stake. SDL security gaps often result in last-minute security patches, emergency response efforts, or even full-scale production outages. If an attackers compromise the development pipeline, they can inject malicious code, delay production launches, or even shut down business-critical operations. We've seen companies lose millions in downtime and remediation costs because of an insecure software supply chain. Finally, there's competitive advantage. Insecure development processes slow down innovation. Instead of focusing on building new features, teams are stuck putting out security fires, fixing vulnerabilities, and responding to breaches. Meanwhile, companies that prioritize SDLC security gain market edge. They deliver secure, reliable software faster and position themselves as trusted providers in industries where security is a key purchasing factor. The bottom line, SDLC security is no longer just about avoiding breaches. Organizations that fail to secure the SDLC don't just risk cyber attacks, they risk losing trust, disrupting operations, and falling behind the competition. So as we've talked about, we had some examples of how these risks aren't just theoretical. And we see all these attacks in the headlines, but we have real data at IDC that they're happening to organizations just like yours. Recent IDC research found that almost 1 in 5 organizations experienced a software supply chain attack in the last 12 months. And this is likely underreported as many companies hesitate to disclose security breaches in surveys. But software supply chain attacks are just one piece of the larger risk landscape. Security misconfigurations, which was the most commonly reported incident in this survey, can leave CI/CD pipelines, cloud environments, and developer tools wide open to exploitation. We also saw compromised credentials and broken authentication provide attackers with direct access to source code repositories and deployment environments that enable them to insert malicious code undetected. And broken access controls can escalate these risks by allowing unauthorized privilege escalation. And then we also saw insider threats as well, at 7%. While a small percentage, this can really compromise sensitive development infrastructure from within. So what's happening is this fundamental shift in how attackers operate. Instead of targeting applications directly, they're going upstream, exploiting gaps in developer identities, tool chains, and open source dependencies to infiltrate software before it even reaches production.
So Katie, it's a mix of multiple different attack vectors that seem to be working in sync almost. That's actually causing a lot of these this risks in the SDLC environment. Is that basically what's the summary of this slide?
Yes, absolutely. And I think what's most interesting here is not only the mix of attack vectors, but that when you look at the orange bars highlight the attack or the incidents that I was referencing in the SDLC oriented ones. Look at the lean, in the chart there. We always talk about stuff like 0 days, and only 1.4% of organizations indicated that was something that affected them, or even stuff like cross-site scripting, or malware, stuff that gets a lot of airtime, more so than, say, insider threats or authentication and access control issues. But yet, those are the things that organizations are really experiencing.
Wow, net, you have to look at all of these different attack vectors in sync or in combination, not look at each one of them, in isolation, I guess. That's
agreed.
Perfect. Thank you.
And ransomware, something not on that slide, a hot topic, right? And it's something that continues to be one of the most pervasive and damaging threats facing organizations today. And a key factor behind the rise of ransomware is that it gives attackers a variety of ways to monetize an attack, right? So unlike previous generations of attacks that, required threat actors to steal and resell data on the black market, ransomware, allows an attacker to immediately monetize a successful attack through, extorting the victim. And, many organizations have a blind spot in the area where ransomware has become most active, the software supply chain. IDC research found that software supply chain attacks were the second leading source of compromise for ransomware incidents in the surveyed organizations. And, this is compelling because the lines between different types of cyber attacks are blurring. We tend to think of ransomware as something where, like, an employee clicks a phishing link and malware, encrypts a system and, that ransom is demanded. But what this data shows is that nearly 1 in 6 ransomware incidents originate from a software supply chain attack. And this is a significant shift in this threat landscape. So to pivot a little bit and to really make this concept of SDLC as a supply chain a little more tangible, I want to use an example I like to use of talking about a cereal factory. So, think about everything that goes into getting a box of cereal onto a grocery store shelf, right? It starts, say, with sourcing the raw materials like your oats, your almond, your honey, and those ingredients are then transported into a processing facility where they're milled, they're mixed, they're shaped and baked. And from there, that finished cereal is then packaged, it's shipped through distribution networks, and finally it's delivered to your local store. And every step along the way represents part of that supply chain. So now if something goes wrong, say the oats supplier delivers contaminated grain, or the processing facility worker forgets to wash their hands, or a packaging machine drops shards of metal into a bag, the impact cascades. It could lead to product recalls, delays, or even harm to consumers. So now let's take that and think about it in terms of a supply chain, the SDLC is a supply chain. In the software supply chain, the raw materials are the components like open source libraries and APIs. And those components are brought in together into the factory of your version control system and your CI/CD pipeline, where they're integrated, tested, and built into an application. And then the final product, your software, is then distributed to users through deployment processes. So just like with the cereal, every step in the software supply chain is interconnected, and a weakness in one part can compromise the entire system. So I think what this diagram highlights is that the software supply chain isn't just about the ingredients. While, when we talk about the software supply chain, we often over-rotate or over-focus on open source as the primary risk factor, and we overlook other critical elements like the tools and the infrastructure that make up the factory. So for example, the security of your build system, or the integrity of your deployment processes, or the credentials of your developers, they all play an equally important role in getting a safe and secure software into the hands of its users. So a breach in any of these areas can be just as damaging as a vulnerability in an open source dependency. So now that we've broken down the software supply chain and all its moving parts, it's clear that there are a lot of stages in the SDLC that are potential attack opportunities. So I'm going to jump in and talk about 3 of the most critical SDLC vectors where attackers are most aggressively targeting software development environments today.
Love that analogy, Katie.
Yeah. So the first one, right? We kind of alluded to this, and we've talked a little bit about identities, but I really want to drill in here on developer and development environment identities. This includes both human and machine. As we look at the most common infiltration points in the modern supply chain, one risk really stands out, and that's stolen credentials, whether it's through phishing, credential stuffing, exposed secrets. Attackers are increasingly using compromised identities to gain a foothold in the SDLC. The problem is that many organizations don't review access frequently enough. As the data from our research at IDC on the screen shows, entitlement reviews often happen quarterly, biannually, or sometimes even less frequently. And that means excessive permissions can persist for months or years, creating unnecessary risk. Developers, build servers, and CI/CD tools, they might retain high privileges long after they're needed, making them prime targets for attacks. So to combat this, organizations need to shift toward an identity-centric approach as a first line of defense. That means minimizing the attack surface by enforcing these privilege access, ensuring that every user, system, and automation only has the necessary permissions for their role and nothing more. And even more importantly, we need to automate identity reviews. Instead of relying on these periodic manual audits where people get spreadsheets together, organizations should really implement continuous monitoring and real-time enforcement of developer and SDLC identities and remove access privileges as soon as they arise. This approach not only reduces operational friction, but it ensures that critical development environments remain protected. And, as SDLC or SDLC attacks increasingly target both human and machine identities, this requires strong identity governance because when credentials are compromised, basically the entire software supply chain is at risk.
So Katie, quick question.
Sure.
I'll digress there for 30 seconds. So these reviews, which tend to be quarterly, is there any automation at all, or is it mostly manual based on the survey that you've done?
Yeah, what I've seen in both the survey and just from conversations with end user organizations is that most of the time this is manual. Only really forward-leaning organizations have are using tools and processes to automate this, whether it's automated some level of identity governance as well as things like, say, just-in-time type permissioning. These tend to be lesser adopted practices. And unfortunately for most people, these things are either happening, I like to say, like a fire drill type incidents where somebody that has really high privileges is terminated, or and they realize that they got to get into sort of a huddle and figure this out, or it's just not a priority and they're just having to review this stuff manually and dig through disconnected systems to figure out where folks have privilege, across systems.
Makes sense why this is one of the most exploited attack vector in the SDLC process. Totally makes sense. Thank you.
Yeah, absolutely. It's disconnected, and if you don't have both the visibility and the automation together, then it's really hard to do effectively.
That's a double whammy there.
Mm-hmm. So then Toolchains is our next critical attack vector, and it's often, I think, one of the most overlooked ones because when the CI/CD pipelines, the artifact repositories, the deployment tools that developers use, they form that backbone of modern software development. And all of these tools hold privileged access and are connected directly to production environments a lot of times, making them a prime target for attackers. If an attacker gets access to a developer tool, they really do gain control of your SDLC. And we've seen this, right, in the real world breaches like SolarWinds and CodeCove, where compromised pipelines enabled attackers to inject malicious code at scale. And this risk continues to grow as more teams accelerate release cycles, as shown in the data on here. I mean, we see over 40% of organizations or almost 40% of organizations are deploying weekly, but we've got, another 33, about a third are deploying daily or on demand multiple times per day. And the faster code moves to production, the greater the chance that a misconfigured tool or compromised credential could introduce a vulnerability, well before it's detected. And I want to harp on identity and access management here again. It plays a role in developer tool chains. Developers frequently use different credentials across various tools that make it difficult for organizations to track and control access effectively. So when you don't, like we talked about with visibility on the first attack vector, without that centralized visibility, it's really easy for credentials to become over-permissioned, orphaned, or exposed, leaving your toolchain vulnerable to exploitation. So organizations really need to establish a baseline for what normal behavior in their toolchain looks like and monitor for drifts and anomalies, such as unexpected privilege escalation or an unauthorized deployment or some change to a sensitive configuration.
Makes sense. It's basically a toxic combination, a toxic interaction of overly entitled identities plus misconfigured toolchains, I mean, that's a recipe for disaster, or at least the beginning of a recipe for disaster, I would say.
Yeah. And when everything's automated and you're pushing code like that third of organization is at least every day, all it takes is, a moment in time to push something through and have another SolarWinds type of incident.
Yep, Katie, that's what we are seeing with our customers too, right? It's never one, as you mentioned earlier, it's never one attack vector. It's a combination of multiple attack vectors that typically lead to sort of a bigger risk for the entire development environment. Makes sense.
And then lastly, the third attack vector that's really critical is open source and third-party dependencies. And I know I kind of said earlier, we over-rotate on it, but I still want to make sure it's emphasized that it is still an important attack vector. Actually, a good example of the combination of both a tool chain and a not quite open source, but a very community impactful effect here is we look at the GitHub action breach that happened over the weekend, right? Very relevant. Didn't have time to incorporate it in writing in this presentation, but it's super related and relevant to all these things we're talking about here, where that one that one piece of the tool chain is compromised and it impacts so many organizations that use that and was printing secrets, and then those secrets get lifted and become the keys to another attack, right? And so this really shows that every organization relies on some sort of open source or third-party component to accelerate development, but most have limited visibility into what's actually inside their software and their tool chains. There's an important thing here is it's not just direct dependencies. Those are sometimes the things we do have visibility into. It's those transitive dependencies, the things that come along with them that are often hidden and can introduce vulnerabilities that developers aren't even aware of, and creating huge blind spots that attackers know are a blind spot and they are eager to exploit it. And as we see in the data here, from an IDC research study on open source use, 65% of organizations have been directly impacted by a vulnerability or a compromise tied to open source software. And we've seen firsthand how attackers exploit widely used open source libraries, taking advantage of known vulnerabilities that an organization fails to patch in time. The Log4Shell incident was a perfect example. We still see the vulnerable and compromised Log4j in usage in organizations, and it's still being exploited. So one of the biggest issues here is that the decision making around open source is often decentralized, and different teams are pulling in different libraries. There's not a lot of formal security oversight or tracking mechanisms, and so when there's this lack of governance, it really makes it easy for these outdated, vulnerable, or even malicious dependencies to slip into production unnoticed. So the bottom line here is that if you don't know what's in your software, you cannot secure it. So finally, I want to pivot to talk about what do you need to do now, right, as an organization, knowing all of this. And I think I hope I've made it clear that traditional security approaches, they're not enough to secure your SDLC. SAS scans, like those kinds of things, a WAF, they are not going to protect you here, right? Security teams are using these point solutions that focus on just one problem or one part of the pipeline, and they have gaps in visibility, inconsistencies in enforcement, and really fragmented remediation efforts. So at IDC, what we've been communicating is that organizations need instead an integrated SDLC security and governance platform, one that provides this end-to-end protection across the entire software development lifecycle and development environment. And so to be effective, I highlighted here some 3 core pillars. First is that it needs to have end-to-end visibility. The first step in securing the SDLC is having that full visibility into every stage of the pipeline. I've said this a couple times and I'm going to continue to harp here that you need this unified view to help security teams monitor access levels, detect anomalies, and identify vulnerabilities before they escalate. The right platform should not only flag risk, but correlate issues to detect things like toxic combinations that we've referred to, right? These coming together of misconfigurations and vulnerabilities and overprivilege that when they come together, they could lead to a breach. And centralized monitoring with real-time alerts and analytics is what allows an organization to take that proactive action rather than reacting to an attack after it's already occurred. Secondly, you need automated guardrails as part of this platform. This is one of the biggest challenges in securing the SDLC is because you need to balance security and speed, and developers need to move fast, but security can't be an afterthought, right? So this is where automated guardrails come in. The platform should provide policy-driven controls that automatically enforce security at every stage of the SDLC, from commit checks to build validations to automated scanning. This should ensure that misconfigurations, insecure code, and vulnerabilities never make it further down the pipeline. And finally, even with visibility and guardrails, security issues are still going to arise. And when they do, how quickly they're remediated matters. And so the problem today is that security findings are often disconnected from developer workflows. That leads to delays, context switching, unresolved risks. A modern SDLC security platform should provide built-in remediation workflows that integrate directly into developer tools. And that's not just Jira tickets, right? You integrate with IDEs, you integrate with systems like GitHub and GitLab and merge and pull requests. That way, security issues can be resolved immediately without disrupting workflows. This also applies to identities. Automated entitlement reviews and things like just-in-time access can help reduce some of those over-permissioning problems. So it's really important here that this remediation process is happening in an automated and frictionless way. So to kind of wrap up here, we've talked about the risks, we've talked about the attack vectors, and we now know that we need an integrated SDLC security and governance platform to address these things. So to wrap up, we need to address the question, what does implementing such a platform actually achieve for an organization? And, beyond just reducing security risk, it really does create tangible business benefits. It improves efficiency, it reduces technical debt, and it aligns security with how modern development teams operate. So, first, one of the big benefits we see of adopting a platform like this is that shift from reactive to proactive, right? Traditional security approaches, they focus on just like testing and maybe securing the final product, but modern threats target the entire process, right? And so SDLC security and governance platforms ensure that security is baked into the pipeline and the process, not bolted on in the end. This proactive governance approach prevents vulnerabilities before they reach production. It helps reduce last-minute security fixes, compliance gaps, and risk exposure. And as regulations increasingly mandate security controls throughout the SDLC, organizations that adopt proactive security, they're not just reducing risk, they're ensuring compliance before their auditors even come and knock on the door. And then a second benefit we see is that consistent security control across teams. Modern development, it's complex. There's multiple tool chains, open source dependencies, and you've got distributed teams, and all of these things introduce inconsistency. And so without some sort of broader governance platform, security controls are fragmented, and that leads to those, greater inconsistencies across teams and tools. So when you have an integrated solution that provides centralized oversight of identities, of permissions, of configurations, it really makes it easier to pinpoint who did what, when, and why, right? And these automated policies can ensure that every team follows the same security standards and can eliminate this human error and overlooked risks. Thirdly, we see cost savings. Every unaddressed security gap represents future cost, whether in a breach response, regulatory fines, or just lost productivity. When security is reactive, teams spend more time fixing vulnerabilities than developing features, and that leads to costly delays. So when security issues cascade through the SDLC, they become exponentially more expensive to fix. By shifting security left, by providing unified governance and visibility, organizations lower operational costs and avoid expensive security failures. And then finally, we really see an improved developer experience. And this is really important. Security is traditionally seen as the no guy, right? The blocker. And slowing down development with manual reviews, compliance hurdles, and rework, organizations really need this governance platform that will integrate directly into developer workflows to eliminate these friction points. Features like automated security checks, just-in-time access, and seamless developer-oriented remediation workflows. It means that they don't have to leave their tools to address security issues. Instead of reacting or viewing security as a roadblock, they're able to work within these pre-approved parameters, and that leads to, faster releases, fewer security disruptions, and an overall better developer experience. So the bottom line, I want everyone listening to understand is that, the securing your SDLC is incredibly important, and an SDLC security and governance platform can really help organizations scale security with development rather than working against it. Organizations that invest in something and like this with governance not only strengthens their security posture, but it streamlines development, it cuts costs, and ultimately will improve their, developer productivity.
Thank you, Katie. That was actually super, super informative. What again, we also sort of pretty much hearing the same thing from our customers, and that's basically the reason why BlueFlag Security has gone in with a platform approach and has been looking at exactly those three attack vectors, right? Developer identities, doesn't matter if it's human or non-human, plus misconfigurations associated with the tool chain, and last but not least, looking at vulnerabilities from an open source perspective or secret leakage, et cetera, right? Now that's fundamentally what we are doing here at BlueFlag Security, which is securing the developer identities or the SDLC identities, plus the misconfigurations associated with tools and all the risks associated with the code. That's basically the goal in terms of the entire platform that we have built here at BlueFlag Security. The 6 key components of the BlueFlag Security platform. Number one, as Katie mentioned earlier, right, our goal is to build a single platform that helps in terms of defending the entire SDLC process, the entire SDLC chain across malicious or risky identities, across misconfigured tool chains or pipeline tools, and the code itself. So that's fundamentally the first thing that we're doing in the development platform, right? Building a multi-layer defense across identities, pipeline, and code. The second key thing that we're doing, as Katie mentioned again, is providing comprehensive visibility and insights across the entire SDLC process, right? And this in turn helps us proactively protect against SDLC threats, as well as not just protect, but also help in terms of remediating against these threats, right? So that's, again, a core element of the BlueFlag Security platform, right? Reduce the attack surface proactively, assume there will be sometimes the breaches will happen, and at the same time, help in terms of the remediation. And the way we do that is by looking at the source of these risks, right? And we apply a developer-first security model to SDLC. And last but not least, one of the core tenets of the overall platform is the ability to standardize on policies while having multiple tools, while having multiple technology stacks for the development environment itself, right? So applying the same set of standard policies or applying the same set of policies across a diverse set of tools that are being used by the developers. That in turn translates to automation from a compliance perspective, automation from a policy enforcement perspective, right? Again, that helps in terms of accelerating or reducing the friction completely. Now, that's basically the core elements of the BlueFlag Security platform itself. And last but not the least is how are customers deploying us? How are they seeing the value from the platform? The way we actually work, number one is we are a SaaS-based solution, very, very easy for you to deploy a platform. All we need is the ability for us to ingest data from your existing SDLC toolchain, right? So for example, we can, give us 15 to 30 minutes and absolutely can start ingesting data from your GitHub, GitLab, or whatever your source code management tool is, right? That's all we need, right? And in addition to that, if you want to sort of let us ingest data from your pipeline tools, your CI tools, your artifact repositories, or even integrate with your IAM tools, right? Literally, all it takes is 30 to 60 minutes for each one of those integrations, right? So that's the first component, right? Second thing that we do is, as part of our overall engagement, we do what's called a risk assessment, right? Again, as I mentioned, takes less than 30 to 60 minutes of your time. And the second thing that we do is, once you've ingested the data, we will provide insights, right? Provide insights in terms of what's the risk associated with your entire SDLC process, from identity perspective, from a misconfiguration of your toolchain perspective, as well as risk from your code governance perspective. Not only are we providing the insight, but we also identify the root cause of the problem, right? Which development teams are causing the most amount, are introducing the most amount of risk, both from a behavior perspective as well as from a vulnerability perspective, right? Not only are we identifying that, but we're also identifying the teams that are actually adhering to the risk, or the least risky development teams, right? And last but not the least, as part of this risk assessment, right, we are obviously providing the insight, but we also provide you with actionable recommendations and how you can remediate this risk. Effectively, this entire process after you're deployed can take as little as 2 days or 48 hours. Worst case scenario, if there's a huge deployment, we can provide this value. We can actually provide you with this insights and the recommendations within a week, right? That's how we interact with any prospect or any potential customer. So that's us in a nutshell, right? Single platform that looks at risk across developer identities, both human and non-human, that identifies the risk across the toolchain, so identifies the misconfigurations, and last but not the least, does the same thing on the code side, right? Identifies the code vulnerabilities. Not only are we identifying the risk across all of these three different attack vectors, but more importantly, we also help in terms of remediation, right? Both automated remediation, as well as if customers want, they can absolutely leverage some of the remediation scripts that we deliver, right? So that's fundamentally what the BlueFlag Security platform is doing. And again, last but not least, at the expense of repeating myself, looking at the source of the problem, which invariably happens to be a development team or engineering or development identity, right? So that's fundamentally what we're doing in the BlueFlag Security platform.
Thank
Maura,
you.
over to you.
Thank you, Katie. It was awesome. Thank you, Raj. So we have about 5 minutes. I have a couple of questions for Katie. This one's interesting. You didn't really touch on AI. So the question here is AI is increasingly being used in software development, no surprise. How do you see AI impacting SDLC security, both as a tool for defenders and as also something that attackers can exploit?
Yeah, actually, I think it's kind of funny we made it through a whole presentation. I don't think we used
Without
the word
any.
AI. It's a
We did
record.
not.
I think a refreshing one. We are AI washed a lot these days, but it is important, and it is increasingly becoming part of the SDLC. So I think you kind of hit on an important thing here. I like to say even AI is kind of like a multi-edged sword in the sense of there's a couple of things to consider. On the positive front, it can really help, right? And you, as we're talking about the BlueFlag platform, right? There are absolutely aspects that where you leverage AI and machine learning to be able to say create that intelligence graph. And there are ways in which AI and models can be used to enhance the way you are doing your security. For example, AI is really great at processing large amounts of data and looking for patterns, and that's something that a human can't go and do with any effective amount of time. So for example, AI could look across unusual code commits, or look for those suspicious patterns across all of your repositories that a human could never identify on their own. But on the other aspect, there's kind of two things here. One, attackers themselves are equally using AI. So it's kind of a race to how much can can platforms and organizations leverage AI to be better, but also to outpace the ways in which attackers themselves are using AI. We've seen them use LLMs just like we developers use to create code and applications. They're using it to create attacks against that code. But I think the other thing too is organizations are integrating AI into their applications themselves, which then become another, I probably would say if I had a fourth, critical attack vector we were talking about in the SDLC, as organizations are, rapidly moving towards putting AI applications into production, that itself, the AI components, the models that often come from things like open source repositories like Hugging Face, those things also have to be, all of these things have visibility, have governance, have automated remediation around them.
Okay. Raj, do you want to, anything you want to add from a blue flag perspective?
Yeah, so look, I mean, that absolutely makes sense, right? So what we are seeing at least is more and more customers are worried that as developers use AI, right, they will produce more. I mean, honestly, it increases the efficiency of the code development quite a bit, but also in 2 years, it increases the chances of the vulnerabilities that get into the code, right? So that's again something that pretty much all our customers, all our prospects are very worried about, right? And then the great thing about, what we have, the way we have designed the overall platform, the BlueFlag Security platform, is fundamentally, like, even if the code is being generated by AI, right, one of the key things that we're looking for is that, how do we actually then go back and assign the risk to a developer or a development team, right? Again, going back to the source of the problem, right? Now that again, what it implies is that from my perspective, the number of vulnerabilities that will come downstream will obviously exponentially increase, but the number of developers will not really increase a lot, right? And again, if you think about the source of the problem, let's go figure out what is that risky behavior by these developers or the development teams. Let's go solve or reduce the risk at the source of the problem, right? Now, again, what it implies again is the more AI that's being used, the more critical it is to actually identify those developers who are actually bringing in this risky code or doing this risky behavior, right? Now, again, that becomes the place where you can actually help resolve the problem.
Yeah, I was going to throw in there real quick that IDC research has found 91% of developers have I believe it was 91%, have use some sort of AI
Mhm.
coding assistant in the work that they're doing. And actually, the most popular one is ChatGPT, which is a little scary so for that. So yeah, it's so important that you have visibility into these kinds of things.
Yeah, and Katie, that's what I meant, right? So vulnerabilities are going to exponentially increase. So if you're only looking at it from vulnerability perspective, as I pointed out earlier, right? It's the problem is already very challenging to identify the right set of vulnerabilities. That's going to become exponentially worse, right? So if you focus only on looking at the vulnerabilities, it's almost a next impossible problem to solve. And I keep saying this to all my customers, right? You're playing a game of whack-a-mole, and the speed at which you have to play the game just increased exponentially, right? And again, again, that's the reason why I have to go back and look at the developers and find those risky developers, make sure you're also proactively reducing the attack surface there.
Yeah.
Okay, I think we have probably time for one more question. And Katie, this is probably directed at you. Raj, if you want to jump in later, please do. So many organizations already have significant investments in security tools. That's no surprise. How should they be thinking about integrating some of these newer, SDLC platforms into their existing environments or security architecture?
Yeah, this is a really critical thing that, that we see that leaders are really thinking about, right? I think we in our IDC research have found that the average organization uses about 10 to 14 DevSecOps tools. And when you broaden that to security tools at large in the organization, 50 is about the average. And so sometimes you might like, well, why another tool, right? And so it's really important to understand that organizations, you need to be able to map all of these things and understand where you have coverage, where you have gaps, and especially around, identity governance, toolchain security. These are things you more than likely are not going to have something already in place to address. And, rather than viewing this solution as maybe a replacement, you really should think about it as that how you're filling in sort of these blind spots in your overall security architecture. And there probably are examples of where you might be able to eliminate some tools, do some consolidation. But most successful organizations, they start with that integration first approach, looking at how you can sort of bring all of these things together and consume data across these existing tools and provide that additional, correlation and context and be able to understand how all of these things work together, right? Per all of the stuff we've talked about with like toxic combinations. So, security is very much has to be this holistic and integrated process. A SaaS tool detecting code vulnerabilities, that that doesn't understand that your developer is over provisioned, right? So it's really important that you have a platform that can integrate all of these things together.
Okay.
And just to add to that, Maura, like what I'm seeing from customers and prospects, right? Look, I mean, almost every, if not all, our customers have started the journey of trying to secure their overall SDLC environment, but they have primarily been focused in terms of buying multiple code scanning tools, right? Where they are is, they're overwhelmed with the number of vulnerabilities that their code has, right? And even with the prioritization, they're struggling to actually sort of, address and eliminate some of the critical vulnerabilities that they're finding in the code, right? So what they are trying to do is like, look, number one, it's overwhelming. B, I'm reacting to risks that already exist in my environment, right? That doesn't help me solve the problem. So how can I take a more proactive approach, as Katie mentioned, right, before? And second is they really want to have visibility and obviously the remediation, right? But the more important thing is how do I get to the source of the problem, right? Either it is how do I identify the misconfigurations with the tool chain, or how do I find the risk associated with the developer identities, human or non-human? Let's go address the risk there, reduce the attack surface so the number of vulnerabilities that are coming into the overall SDLC process reduces so that I can then manage it, right? That's been literally consistently, that's what customers and our prospects are articulating, right? Please help us map this and identify those risky development teams or risky identities, and please help us identify those misconfigured tool chains, etc. Right? So fix the problem there proactively so that I don't have to rehack and play a game of whack-a-mole. Right? That's literally what we are hearing from all our customers. And last but not least, and this is to some extent, you'll see that there's a huge movement in terms of platformization of the different security tools, right? Certainly seeing this on the cloud infrastructure security side. We're seeing the similar movement in the developer security side, right? So they're looking for a single platform that can help them manage security across the entire development environment of the SDLC process itself. That's what I'm seeing, at least from our customers, and that's the reason why we're seeing such good traction from our prospects too.
We see the same thing in our survey data in the end user conversations I have. Organizations are looking to invest in their strategic platforms that there's never going to be the one platform to rule them all, right?
Exactly.
But very much organizations are looking to find strategic vendors that they can work with that provide them that control plane, that single, point of visibility, and be able. And so this is where I've seen tools like this, SDLC governance and security space evolve because organizations really want to be able to have that platform that helps them understand this whole process that's often a black box in a lot of organizations, particularly from the security point of view.
And Maura, I forgot to mention this, right? The other piece that almost sort of invariable, the application security team, the CISOs, and even the CTOs are articulating is, look, we don't want yet another platform or tool to give us more wisdom or more insights only, right? Absolutely critical to do remediation. Doesn't matter if it's automated remediation, guided remediation, or even the basic simple thing as like, give me a remediation script, right? That's absolutely essential for every customer I'm talking to.
You're hearing that from everyone.
No remediation. If you don't provide remediation, let's not even bother.
You're just telling me all this stuff that is a problem, but you're not telling me how to fix it.
Don't tell me what the problem is. Help me solve the problem, right? That's the big piece. And last but not the least, and then I'll shut up, right? The last thing that they're articulating is like, look, you need to be able to work with some of the tools we have standardized, right? Like, our customers, right? If they're already using a code scanning tool, a SAS tool, a CA tool, but that they've already standardized, the last thing they want to do is hear us say, we can replace that, right? Day zero, that's not really what they're trying to do, right? What they're trying to do is, I've already invested in a bunch of code scanning tools, etc. Help me extract more value, because right now we are struggling to get that, right? Help me sort of, again, correlate that back to the root cause and help me remediate the problem, right? That's really what we're saying. Over a period of time, as Katie mentioned, absolutely they'll be looking to replace some of those point solutions with a platform, but that's not what I'm seeing, at least when the customers deploy us immediately, or in fact any platform like us.
Okay. All right. Well, thank you. That was incredibly insightful and valuable. I hope everyone listening gets as much as I got out of it, even though I work at BlueFlag. So thank you again, Katie, and thank you, Raj.
Yeah, thanks for having me. This was fantastic.
Thank you, guys.